Assistant Professor, Department of Mathematics, Dr. SNS, College of Arts and Science, Coimbatore. In these previous videos, already we discussed the initial basic feasible solution of transportation problem using by northwest corner rule, and another method is least cost method. Discuss the method is called Vogel approximation method, shortly we call as VAM. V for Vogels, A for approximation, M for method. So using this method, we find the initial transportation cost and the initial basic feasible solutions. Before that, we check whether the given transportation problem is balanced or unbalanced using by the total supply and the total demand. If these two are equal, then the given transportation problem is balanced. If it is balanced, there exists a feasible solutions. Okay, so let us go to the applying this method. We find the initial transportation cost. We got the process to find the initial basic feasible solutions using by this Vogel approximation method, or is called penalty method. So what is penalty? First we take row penalty. So first we get the row penalty. What is row penalty? Using this first row, we choose the two minimum cost. So 1 is minimum and 2 is minimum, and we take the difference 2 and 1. The difference is 1. That is called penalty. And it takes second row. The minimum is 0. Next is 2. So difference of these two. 2 minus 0 is 2. That is second row penalty. And that third row penalty, we choose minimum cost is 1. Next minimum is 3. So 3 minus 1 is 2. So these are all called row penalty. Using by column penalty, using this first column, we choose two different least costs, and what is the difference? So 0 and 1, difference is 1. Next, here 2 and 1, difference is 1. 2 and 5, difference is 3. So this is the meaning of penalty. Now, in this row penalty, we choose the maximum penalty is 2. In the column wise, maximum penalty is 3. 2, 3. Among these two, which one is maximum? So 2 is maximum, we use a arrow, and we choose this third column. Using this third column, we apply the least cost. So among this all the cost, which one is least? 2. So we fix that and we check it. The corresponding supply is 12 and the demand is 10. So from that we take 10 supplies and fill this demand. Still we have 2 supplies available. Here there is no demand because we fill the demand. Therefore there is no demand is there. So block this remaining cells. So that is the first way. Next we go to the next second penalty. So here the second penalty, the difference of these two is 1. The difference of this 0 and 4 is 4. And the difference of 3 and 1 is 2. That is second penalty. And a column wise penalty, there is no cancellation. We have 1 here, all are blocked. Therefore we use dash. From the second penalty, the maximum penalty is 4. Here the maximum penalty 1. Among these two, 4 is maximum. Therefore we choose this arrow. Corresponding here, we choose the smallest cost is 0. So choose that. Supply is 2, demand is 10. Therefore we take 2 supplies, transfer or shift here and fill that 10 by using 2. Still we have 8 demand is there. From that there is no supplies available. So block this remaining. Then we go to the third penalty. So what is third penalty? So difference is 1. Here all are in there, so block. Then the difference of this 3 and 1 is 2. Similarly for here, third penalty, 1 and 3 because it is already filled. So 1 and 3, difference is 2. 2 and 1, difference is 1, already is blocked for dash. The third penalty that side is maximum 2, here maximum is 2. 2, 2. Among these two, which one is chosen to enter? Is our choice, but that 2 is in third row, but this one is first column. Therefore we choose this, or we give the preparation for the row side as our choice. Suppose we choose that we apply the least cost. So 1 is least, supply is 7, demand is 8. Therefore take 7 supplies and until this demand we have 1 supply available. There is 1 demand is there, and there is no supplies available from that side. So cancel. So remaining here there are 11 supply is available, but there are 1 plus 10, 11 demand is there. Therefore we split as 11, 1 and 10. So 11 can split up by 1 and 10. So it will complete. So it is a very satisfied. Then number of basic cells before that, whether it is non-degenerate or degenerate. So using that, how many basic cells? 1, 2, 3, 4, 5. So number of basic cells bases are 5 and the m plus n minus 1. M plus n minus 1 is m is number of rows 3, n is number of column 3, minus 1 is equal to 5. Therefore, non-degenerate solution. Non-degenerate solution. Okay, right. Then what is initial basic feasible solution? Where is this occupied cells? This 7 is in first row, first column, therefore it is 7. And this 2 is in second row, first column, is 2. And this 10 is second row, third column, it is 10. And this 1 is third row, first column, is 1. And that one is third row, second column, is 10. So that is initial basic feasible solutions. Next, initial transportation cost. Initial transportation cost. So that means here we transfer 7 products and we assume each product is 1 rupee. So 7 into 1 is 7. Therefore it is 7 and plus, and we transfer 2 products but it is 0 cost. Therefore it is 3. So 0. There are 10 product transfer here. Each product has 2 rupees. Therefore 20 rupees we assign. And then 1 product transfer. Each product has 3 rupees. So 3. 10 into 1. So 10 product 1 rupee. So 10 into 1 is 10. 10 into 1 is 10 plus all. So the initial transportation cost is 7 plus 20, 27, 30, 40. So 40 rupees. So that's all this method. So initial basic feasible solutions using by this VAM method is very powerful than the least cost method and the northwest corner rule. Therefore this method is advisable to find the initial transportation cost, because suppose you apply the same method for least cost method and the northwest corner rule, the initial transportation cost is just vary, but it is very simplified form, and you try to reduce the transportation cost using this method is applicable than the two method. Therefore, this VAM method is very powerful than the least cost and also